Now let's see what is the difference between mass and weight. Okay, and how they're different, right? So very first, let's see what is mass. Mass is basically the total content of the body, which measures the inertia of the body, right? Okay, means everything which you can see surrounding you is made up of some, some material, some substance, right? And in that material, there are a number of, atoms and molecules and particles are there, right? So mass is that matter, right? Mass is that matter, that content, right? By which that body is made of.
Head of.
Are you getting that? Okay. So just write down mass is the total
Ma'am,
content.
ma'am,
So it is the total content of the body. Okay. So what is the mass? Mass is the total content. It is the matter, right? By which that substance, that, that body is made of, right? And this measures the inertia of the body. Okay. So mass of the body tells about the inertia of the body.
yes, ma'am.
Okay. Right. Now this mass represented by small m, right, is a scalar quantity, right? So there are two types of quantities. You already know the scalar and vector quantities,
Miller
right?
and vector, yes, ma'am.
Scalar quantities are the quantities which are only with magnitude. There is only magnitude. Okay. Direction is not important. Whereas the vector quantity have magnitude as well as direction. So mass is an scalar quantity, right? Okay. Like similarly, we have speed, which is a scalar quantity. Okay. Time is scalar quantity, whereas velocity, acceleration, force, these are vector quantities where there is magnitude as well as direction. So mass of a body is a scalar quantity and its SI unit of mass is kilogram. Okay. The standard unit of mass is kilogram, kg. Okay. So we can say that, in other words, what is mass? Mass is the quantity of matter contained in the body, right?
Yes,
So what
ma'am.
is mass? Mass is the quantity of matter. It is the quantity of matter contained in a body. Okay. So irrespective of the position of the body in the universe, mass is always remains constant. Okay. Mass is always remains constant. Mass is a universal constant. Mass cannot be changed. It, for a particular body, the mass of that body will remain same in the whole universe. Is that clear? Okay. So position of the body can be changed in the universe, right? Position of the body is relative, right? It can be changed. But mass, it always remains constant, right? So write down mass of the body is always remains constant. Okay. Right. Now, there is one more physical quantity, that is weight, which is similar to mass, right? So put the heading weight. So what is weight? Weight of an object is the force with which it is attracted towards the earth. Okay. So don't confuse between mass and weight, right? So weight is what? Weight is the force by which any body is attracted towards the earth. Okay. So write down the way of an object is the force with which it is attracted towards the earth. Okay, so what is weight? Weight is a force. Okay, mass is m, where but w is the weight. It is the force by which it is attracting towards the earth, right? So as we know that force is what? Mass into acceleration, right? Mass into acceleration, F is equal to ma by the Newton's second law, right? So here this force is w, weight, and this is equal to m. M is the mass of the object into acceleration. This acceleration here this time is the acceleration due to gravity, right? So therefore your formula is w is equal to m into g. So instead of a we will write here g, because since a body is attracted towards the earth, the acceleration produced in the body will be the acceleration due to gravity, right? So that's why instead of a we will write it here g, right? And this force m into g is represented by w, right?
W.
It is called weight. So what is weight? Weight is not the mass. Weight is the force.
वैसे
Force.
वो मतलब एक ऑब्जेक्ट का ग्रेविटेशनल
So weight is a force, right? And the formula for weight is m into g, right? Mass into g. G is the acceleration due to gravity. Okay, so write down where m is the mass and g, mass of the object. G is the acceleration due to gravity. Okay, so this is weight represented by W. Okay, now since we know that G, what is the value of G? G is capital G m upon r square, right? Small g and capital G, the relation is G is equal to G m upon r square, right? So if we replace this within the formula of weight, then W can be represented as m into G m upon r square, right? Or you can write down W is equals to G m m upon r square. Okay, is that clear? Right? Where capital G is a universal constant. Okay, capital M is the mass of Earth, small m is the mass of the object, and r is the radius of the Earth. Right? Okay, getting that. So
Okay.
there are certain important points regarding weight. Okay, and what are those points? Weight is a vector quantity.
Yes, ma'am.
Why? Because weight is a force. Force is a vector quantity, right? So weight is a vector quantity, whereas mass is a scalar quantity, right? Okay, and it acts in vertically downward direction. It is always working in the downward direction, right? Okay, means if suppose there is a object on the ground, right, then its weight is this force mg. The direction of this force is always in the downward direction. Okay, so right now weight is a vector quantity and it acts in vertically downward direction. Okay, now the SI unit of weight, since weight is a force, so SI unit of force will be the SI unit of weight also, right? So the SI unit of force is Newton. So therefore SI unit of weight is also Newton. Okay, is that clear? Okay, so if we say weight of 1 kg mass, right? What is the meaning of weight of 1 kg mass? What does it mean? Means this is 9.8 Newton, right? Okay, so weight of 1 kg mass means W is equal to M into G, right? M is 1 and G is 9.8, so it will become 9.8 Newton. So what is the weight of 1 kg mass? It will be 9.8 Newton. Okay, so what do you mean by 1 kg weight? 1 kg weight is equal to 9.8 Newton. Is that clear? 1 kg weight. When we say 1 kg weight, right? So how we measure our weight? Like 2 kg, 3 kg, 10 kg, 15 kg, right? So what is this weight? This is actually force, right? So if you multiply this with 9.8, that is the force. Okay. So 1 kg weight is equals to 9.8 Newton. Is that clear? Okay. Then important point, next important point. Weight of an object is not constant. Okay. Weight of an object is not constant. Is that clear? It is not constant. Whereas mass is constant. Mass is same all over the universe, but weight of an object will change. Okay. So weight of an object is not constant. It changes place to place. It changes from place to place. Right? Okay. So if you go to some other planet, your weight will be different. Right? So whatever is your weight on Earth, your weight will be different if you go some other planet. Right? Why? Because there acceleration due to gravity will be different. The value of G will be different, and that's why W will also be different. Is that clear? Now we talk about the space. In the space, what is the value of G? G is 0, right? So weight of any object in space is always 0. Okay. So weight of an object in space is 0. Why it is 0? Because there G will become 0. Acceleration due to gravity is 0. Getting that? Then the next important point, at the center of the Earth, weight becomes 0. Right? So if somehow we go to the center of the Earth, right? What will happen? The weight will become 0. And this is because that the going downward to the Earth, the value of G decreases. And at the center of the Earth, the value of G becomes 0. Right? So the value of G will decrease if you go inside the Earth towards the center of it, or if you move away from the Earth, right, in the sky, then also the value of G decreases. Is that clear? So the value of G is maximum at the surface of the Earth. Okay, so if you go inside the Earth or if you move upward in the upward direction in the sky, then also the value of G will decrease after a certain height. Okay, so write down. So what is the value of the G at the center of the Earth? It becomes 0. So at the center of the Earth, weight will be 0 because going down to Earth, going down to the Earth, value of G decreases. Okay, and at the center of the Earth, and at the center of the Earth, the value of G becomes 0, right? So in space also value of G is 0. At the center of the Earth also the value of G is 0, and therefore the weight these places will be 0. So I hope you're getting this. Yes or no? Please note it down. So from these formulas, it is very clear that weight of an object will change on a planet other than the Earth. right? Because there the value of G will be different, right? The spring balance is generally used to measure the weight of the body, and the pen balance is generally used to measure the mass of the body. Okay, so spring balance is used for the measuring the weight of the body, whereas pen balance is used for the to measure the mass of the body. Okay, please note down to here. Now, put the heading weight of an object on the moon, right? So let's see what is the weight of an object on the moon, right? Let the mass of an object is m, right? Let it be m, right? And its weight on the moon, we're talking about on the moon, right, is suppose Wm, right? Okay, m is the mass of the object, right? And this mass is always remain constant wherever you go in the space, right? So it will remain m whether you are on the earth or on some other planet, but weight on the moon will change, right? And that's why we represent it as Wm, means weight of the object on moon, right? So suppose m is the mass of the object and Wm is the weight of the object on the moon. Now, suppose the mass of the moon, because moon is also having some mass, right? So mass of the moon is mm, right? This is the mass of moon, suppose, and its radius, and suppose its radius is rm, right? So we are putting mm in the subscript. Now, according to universal law of gravitation, what should be the force? Write down. According to
question.
according to the universal law of gravitation, because every two objects is attracting each other, right, with some force, right? And that force is F is equal to Gmm upon R square, right? Okay. So what will be the formula now according to the universal law of gravitation? So Wm, because here this time force is weight. Weight is the force. Wm. This will be equal to G. G is the universal constant. M, mass of the moon, which is mm, into mass of the object, small m, upon R square. It means radius of moon, square of the radius of moon. So radius of moon is Rm, so the square of it, right? So what will be the force between the two objects? Means that object and the moon, they will be attracted with the force, that is Wm is equal to Gmm into m upon Rm square. Now, let the weight of the same object is not changing, it is the same object, on the earth, right? Now, suppose the weight of the same object, mass will remain same, right? Mass of the object on moon, on earth will remain same m, right? But weight will change. Okay. So suppose weight of the same object on the moon, on the earth is We. Okay. This is We, right? Now, mass of the earth is suppose Me, mass of the earth. Okay. Now, what will be the radius of earth? Radius of earth will be suppose Re. Getting that? Okay. So Me is the mass of earth, Re is the radius of the earth, right? And We is the weight of that same object having mass m on the earth. Is that clear? Okay, so now, again, according to universal law of gravitation, right? We can find We means the force it will be attracted, right? So this will be equal to capital G, universal constant, m e m upon re square, radius of the earth, right? Okay, so here we were taking mass of the moon and radius of the moon. Here we will be taking mass of the earth and radius of the earth. Is that clear? M, small m will remain same because this is constant all over the universe. G will remain same because it is a constant all over the universe. Okay, is it clear? No. Okay, now what we will do? Let's divide Wm with We. Right? So we have two equations here. This is equation number 1, equation number 2. Right? So dividing equation number 1 with 2. Wm upon We. So what we'll be getting? So write down Wm is Gmm into m upon Rm square. Right? So write down Gmm into m upon Rm square. Right? Now what is We? This is Gmem upon Re square. Right? So we have put it the values of both here. Getting that? Right? Now G will cancel. Right? Will cancel. That's it. So what you are getting now? Mm upon Rm square upon Me divided by Re square. Right? So this is a fraction upon fraction form. Right? So whenever you have a fraction upon fraction form, this will go and multiply with here, and this will be multiplied here. Right? So what you will get? Mm into Re square upon Me into Rm square. Right? M into Re square upon Me into Rm square. Now, since we know all these values, right? We already know what is the mass of Earth. We already know what is the mass of the moon. We already know what is the radius of Earth and moon, right? So we can put the values here, yes or no, to find the ratio Wm upon We. Getting that? So now, let's see what are the values. What is Mass of the moon. It is 5.98 into 10 to the power 24 kg, right? Whereas mass of Earth, Me, this is 7.36 into 10 to the power 22 kg. Okay. Now radius of moon, it is 1.74 into 10 to the power 6. Okay. Whereas radius of Earth, this is 6.37. 6.37 into 10 to the power 6 meters, right? Is that clear? So these are the radius of moon and Earth. Now we will put these value in this. Suppose this is equation number 3, Wm upon We, right? Okay. So now putting the values in equation number 3, what we get? Wm upon We, this is equal to, now put the values. What is This is your right? So write down 5.98 into 10 to the power 24. Re square. Re is this one, right? So 6.37 into 10 to the power 6 whole square. Okay. Now divide by Me. Me is 7.36 into 10 to the power 22. So write down. And Rm, right? Rm is this 1.74 into 10 to the power 6 and square of this. Getting that? So we have put it all the values here. Okay. Right? So now what you are getting? 5.98 into, so we will separate the decimal term, 6.37, and we have a square also here. So we will write down 6.37 into 6.37, right? Into 10 to the power 24, right? So write down 10 to the power 24. Now this is 10 to the power 6 to the power 2. So it will become 10 to the power 12. 6 into 2, right? Power get multiplied upon. Now write down here in denominator 7.36. 7.36 into 1.74 ka square hai, right? So we will write down 1.74 into 1.74 into, now 10 to the power 22. So we will write down here 10 to the power 22. Then 10 to the power 6 to the power 2. So again 12, 10 to the power 12, right? Okay, so this will cut, right? If you subtract 24 and 22, this will be 2 only, 10 to the power 2, right? Okay, right? Now, solve this. What you will be getting? So now we can calculate this, right? So 5.98 and 6.37 into 6.37. It is about 242.64 divided by 7.36 into 1.74 into 1.74. This is 22.28. Okay. And here we are having 10 to the power 2. Okay. Right. So now what you will be getting? Okay. So since we have got this equation number 3, so we will put the values, right? M, that is mass of the moon, 7.36 into 10 to the power 22. Mass of earth, 5.98 into 10 to the power 24, right? Similarly, Rm, radius of the moon, and Re, radius of the earth, right? So we will put these values within the formula, within this, right? Okay, we have, okay, and we will solve this, right? So we can separate the decimal points here, decimal numbers, right? And then we can multiply. So we will get 298.64 in the numerator and 18.10 in the denominator, right? Power of 12, 10 to the power 12 will cut, right? And 10 to the power 22 here, 10 to the power 24 here. So we will get 10 to the power 2 in the denominator, right? Okay. So after solving this, we will find that what is the ratio? This ratio is coming 1 by 6. Is that clear? So this ratio is coming 1 by 6. So what does it mean? That Wm upon We is equal to 1 by 6. Okay. Or in other words, what we can say, that Wm means mass, or sorry, weight of any object on moon is 1/6 of the weight of that object on earth. Okay. So it will become 1/6 of that. Right? So what is this ratio? 1 by 6. Means if somebody is weighing 36 kg on earth, then what will be the weight of that person on moon? It will become 1/6 of 36. That is only 6 kg. What will be the weight of the moon? It will be 1/6 of the weight of that object or the person on the earth. Right? So weight of any object on the moon is 1/6 of the weight of that object on the earth, right? So this is the relation between Wm and We. Is that clear? So there is a joke on the WhatsApp, if you seen that, like if somebody is fat, so uh, his friend is saying like, you are not fat, you are on the wrong planet, right? So you are not fat, you are on the wrong planet, right? Okay, so because on other planet, the weight will be less, right? If somebody is fat and having a weight of like 80, 90 kgs, right? So if that person go to the moon, his weight will be actually 1/6 of it, right? So you are not fat, you are on the wrong planet. So this one time I heard this. Okay. So right now, weight of an object on moon is equal to 1/6 of the weight of the object on the earth. Okay, so this is the relation between weight of the object on the moon and weight of the object on the earth. Right? Okay, so in the next class we'll be doing some questions based on this, right? Weight and mass. Okay, and we will start thrust and pressure, right? Okay, like what is the pressure in the fluids, buoyancy. Okay, so this we will cover in the next class, the density and Archimedes principle. Okay, okay then, ending the class for today.